Hi everybody, Patrick here from EEPROM This video will serve as a video manual for my single RFID reader set maglock controller. It comes with 5 RFID cards, controller board, reader board, stereo cable, USB cable, 12 volt 2 amp power supply, maglock set, so maglock bracket mounting hardware, a 2-pin button connector for reset, a 2-pin cable for signal interface if you want to use it as an option, 4-pin female to female connector, and 4-pin female to male connector. So first things first, let's connect everything up together and program in some cards. If you want a demonstration, just skip ahead. We'll talk about how to program the reader later. It's very simple. First things first, let's connect the female end of our 1.5 meter long USB cable to the male bit on the reader board, and that is connected. We want to connect the other end, the male end, to the leftmost female socket. We want to connect one end of our stereo cable to this jack. It says odd out for audio out, and we want to make sure that this jumper is set to the A line and not to the B line. We want to take our button cable, the 2-pin cable, and red and black does not matter. We want to connect it to the rightmost header here, labeled key 3. Connect the other end of your stereo cable to your computer speakers, the audio input on your computer speakers or Bose player. Your magnetic lock will have a red wire and a white wire, or a red wire and a black wire. Red is positive and white or black is negative. We're going to connect the maglock to this terminal block right here. There are 2 terminals labeled BLK and RED, so black and red. Connect the red wire from your maglock to the red terminal, and connect the black or white wire to the BLK terminal. Make sure that you have these terminals tightened. Don't over tighten them because you'll strip the screw, but make sure that they're tight and that your connections are secure. Everything is now connected. We've got some extra cable connections. They don't matter right now. We'll come back to those later. But now, before we power up for the first time using our power adapter, we'll plug in right here. What we're going to do is we're going to program in our 5 cards. But first, we have to set the jumper, the 2-pin jumper, to program mode. So I'm going to show you how to do that right now. Set the jumper to short pins 11 and 10. And so when we power up, we will be in program mode. Once we're done, we'll short pins 10 and 9. When you power up, the power light on the regulator board should light up, and we are powered. As well, the maglock should be fastened, magnetized, which it is. When powered on, you will also see the little green or red power LED on the reader. So to program, take out your 5 cards and place them over the reader. That card 1, you'll notice that the blue LED lights up after reading a card. Card 2 is programmed. Card 3 is programmed. Card 4 is programmed. Card 5 is programmed. And once all 5 cards are programmed, the blue LED stays lit up, and at this point remove power and set the jumper to short pins 10 and 9. When doing this in power off, you set the reader into scanning mode on power up, which means it looks for the card data of the 5 cards that we programmed in. Any other cards will be rejected. When it reads one of the 5 cards, the blue LED will light up. When an incorrect card is red, the red LED will light up. Now when we power back up, in scanning mode, if I take any of the cards and place it in front of the reader, keep in mind that the maglock is locked right now.
Access card 1 detected. Magnetic lock deactivated.
So card 1 was read. To reset, press the red button.
Magnetic lock activated.
Okay, so let's try card 2.
Access card 2 detected. Magnetic lock deactivated.
So I believe this one, going from the bottom, will be card 5.
Access card 5 detected. Magnetic lock deactivated.
So it works like that. Any single card that has been programmed will release the mag lock. However, what if we reset
Magnetic lock activated.
and we place a card over top of the reader that is not programmed?
Access card denied.
Here's another one.
Access card denied.
So that's how that program works. Now, let's look at the second program. You'll notice this 3-pin dip switch right here. Program 1, which we just saw, is when all of the dip switches are in the off position. However, if when powered off, I turn dip switch 3 to the on position, then we are in the second program. So let's power up and look at the second program. Power it up. Mag lock is locked. In this program, I need to read all 5 cards in order to release the mag lock.
Access card 1 detected. Access card 2 detected. Access card 3 detected. Access card 4 detected. Access card 5 detected. Magnetic lock deactivated.
And we reset, of course, by pressing the red button.
Magnetic lock activated.
And so there we have it. That is the set as it is. Now let's talk a little bit more about the outputs from the reader to the main board and the output from the main board to whatever external circuit you'd like. For this I'm going to employ the oscilloscope. We've got our button connected to the key 3 header, but now we've got an empty connection that's not connected to anything at this point. You want to have the red wire to the left and black wire to the right from this position, because black is ground and red is the signal wire. And what we're going to do is we're going to see how what the board does when it receives an incorrect card and when it receives a good card. And what you can do is you can interface this line with your own external circuit. If you wish to talk to other circuitry, you can write a program that counts pulses, because what happens is when the board receives a good card or a bad card, it pulses a specific pattern to the output line that you can write a piece of code to do with what you wish. Anyway, so what I'm going to do is I'm going to connect my oscilloscope probe ground to the black wire, and my probe itself to the red wire, so we can actually probe the output of this board. Just like that. When the unit reads card 1,
Access card 1 detected. Magnetic lock deactivated.
we get 1 pulse. That's about 15 milliseconds. 1 pulse from positive to negative. So what we're going to do is we're going to count the falling edge. So 1 falling edge is card 1. 2 cards. Or second card.
Access card 2 detected. Magnetic lock deactivated.
2 negative swings. 3.
Access card 3 detected. Magnetic lock deactivated.
3 falling edge. When card 4 is red.
Access card 4 detected.
4 falling edges.
Magnetic lock deactivated.
And card 5, this will be the last one. This will be a pattern of 5 falling edges, and then returning to 5 volts.
Access card 5 detected. Magnetic lock deactivated.
Okay, so now if we get an incorrect card,
Magnetic lock activated.
what happens is it'll send 6 falling edges. So anything above 5 falling edges is an incorrect card.
Access card denied.
So if you ever want to interface with that line, what we've got are about you've got about 50 millisecond pulses from 5 volts to 0 volts to 5 volts again, and 1 pulse low is card 1, 5 pulses low is card 5, and 6 pulses low is an incorrect card, and anywhere in between. So now let's talk about the reader itself. The reader is very similar in how it communicates with the main board. So you can use this reader and connect directly to your Arduino, and that's where the other cable connections are going to come into play. So what I'm going to do is I'm going to show you where to connect to. So we can use our cable connectors, whether you want to use the male to male or female to female, and solder to these 4 lines. So let me talk first things first. Let's solder to those 4 lines, and then we'll worry about how to connect them to your Arduino. For simplicity's sake, I'm going to use these 4 female to male connectors because I can easily connect them to my Arduino. Now I'm not going to show you how to connect directly to your Arduino, but I'm going to tell you what lines do what, and so it's essentially there's 5 volts. So there's a power supply line, a ground line, an incorrect card line, and a correct card line. So first things first, what I'm going to do is I'm going to cut the female ends off of these connectors, and I'm going to solder them gently to each of these 4 lines. Okay, so from the left, from this position, we've got our 5-volt power supply line, out bad. So this signal is used when an incorrect card is read. Gray, third from the left, is out good. So out good, the out good line is used when a correct card is read. And to the right we have ground. So blue is 5 volts. In this case, your color, the color of wires you're using might be different if you plan to go this route. But we've got blue 5 volts, green out bad, gray out good, and purple ground. So what I'm going to do is I'm going to connect 5 volts to blue, I'm going to connect the 5 volt ground to purple, and then we'll probe both the green out bad and gray out good lines to see how they react when a card when the cards are read. So I'm going to power that up now, and I'm going to break out my oscilloscope, and we're going to probe it. So I've got 5 volts connected to blue, DC ground connected to purple, also the negative clip from my oscilloscope to my DC ground, and right now I am probing the green out bad line. So this line only reacts when an incorrect card is read, like this. And again, the red LED lights up. So what I'm going to do is I'll show you my oscilloscope. What happens is when this occurs, the out bad line is set for 200 milliseconds and then cleared. Okay, this is an incorrect card. As you can see, 0 volts set for 200 milliseconds and then cleared. So when this is seen on the out bad line, that means that an incorrect card has been read. Now I'm probing the out good line. Card 1 on the out good line. A 100 millisecond pulse. Card 2. 2 100 millisecond pulses. Card 3. 3 100 millisecond pulses. Card 4. And card 5. And so basically you count the pulses, that is what card has been received. You write a program that pulls, waits for activity to happen on the negative or positive lines, or the out bad or out good lines, and once there is activity on either, write a program to work accordingly. Count pulses on the out good line, or just detect any activity on the out bad line. So thank you for watching. This has been the video manual for the RFID maglock reader. It's got 2 programs, and if you purchase the set, you can ask for the code for the reader. And one last thing I'll mention is the reader has its own Arduino chip. It's an Atmega 328PU chip, and so you could program this to work however you'd like. So thank you for watching, everyone. I appreciate it. I hope you have a wonderful Christmas.